That mean me and Kelly can't talk?
No, yes, we can't talk, unfortunately. That's exactly what it means.
You should sell the rock.
I'm sorry?
I have a question.
Yeah.
On the map, you two are blanked out.
No, they're not blanked out, but the lines that would separate them are gone because they're all the same. So the kinetic energy for A is a constant value. The kinetic energy for, the potential energy for A is a constant value that you're going to use in each one of those exercises.
It's just kind of ran big.
Yeah, it's one value for all 5 of those exercises. Good question. Okay, 5-1. So take out 5-1, put 5-3, 5-4 aside for a second. Now, like I said, you need to be able to evaluate exercises that don't have numbers. Okay? You're going to encounter this in the ACT. You're going to encounter this in the AP test for math and science. They will give you exercises that don't have numbers. You need to express your answer in terms of variables given. Okay? Does that idea make sense? First of all. Okay, number 1. What is the work done on the crate by the applied force? What do you got? Force times displacement, exactly. It's just F, the applied force, times displacement. Yeah, just FD. Work is just FD. Okay. Any questions about that? Okay. Don't make it more complicated than it has to be. Number 2. What is the work done on the crate by the gravitational force exerted on the crate by the Earth? This one's tricky because friction is present. What do you got? Exactly. Fg sine 30, which is your force parallel times displacement. And again, you can't use, we mentioned this earlier today, you can't, to some people, you can't use Fg times the height because 2 reasons. 1, height's not there, and 2, you have friction present. Because you have friction present, you have to express it in terms of force parallel. Nod your head if that makes sense to you. Okay, cool. This is on your test, by the way. Oh, no. It's not this week. It'll be after a break, but it's on your test. What is the work done? Yeah. Thanksgiving break coming up, so it's going to be after Thanksgiving break. We will have a quiz on Thursday. Oh, but it's going to be basic energy and power. Still, I know. Oh, okay. Yeah, whatever.
So we're not doing fancy variable on this stuff?
Not the test. I'm sorry? I haven't decided yet. Party. Yeah, you can bring the cake. It's going to depend on what we actually have to. It's going to depend on what we get done on Thursday. Because Thursday we have the packet. It's going to depend on how much we get done. Number 3. Can we get back to work? Let's get back to work. Number 3. What is the work done on the crate by the normal force with a magnitude of Fn exerted on the crate by the ram? Anyone? Okay. Ft cosine 30. Anyone else? Ft cosine 30. I think. Did anybody choose 0? Exactly. Displacement and force normal are perpendicular to each other. So since they're perpendicular to each other, the vectors are perpendicular, they don't work together, work is 0. Again, remember, when we're looking at work, force times distance, those vectors need to be in the same direction. Or at least have a component in the same direction. Since displacement is this way, and force normal is this way, they are perpendicular to each other, 0 network. Okay. I want to make sure that, that makes sense. Can I get a thumbs up if that idea makes sense? Okay. Question?
So it's not technically wrong to put FND, right? That's just 0, right?
Yes. Yeah. Yeah. It is FND, but since no, it's not FND because they're perpendicular to each other, and D would be 0. So it would have to be a different D. D is actually the D that is up the ramp, so you have to use some other variable. So Fn, I don't know. Fn perpendicular to that distance would be 0. So yeah, easier just to say 0. Yeah.
When it comes to any work, they have to be in the exact same direction.
Or have a component in the same direction. So just like when we were pulling the wagon, and you were pulling at an angle this way, but the wagon was moving horizontal, work was done because there's a component of horizontality, if you will. There's a horizontal component of what you were pulling.
In that case, we don't care about the vertical.
Right. Yeah, because the displacement was horizontal. Does Does that idea make sense?
Yeah.
Okay. It's a big deal. It's a big deal. So there have to be, vectors work together and they have to be parallel or a component. Okay. Number 4. What is the work done on the crate by the friction force Fk? Anyone got an idea?
Minus FKD.
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 Yeah, it's just FkD. FkD. If you want to put a minus in there, fine. That's fine. You can do that. You don't need it because work is a scalar, so you don't need it. It can just be FkD. It's a scalar. Don't have to worry about the negative. I love these questions. Number 5. What is the total force acting on the crate? 0. Why do you say 0?
Because it's constant speed.
Excellent. It's a constant speed. The crate is moving at a constant speed. Constant speed means acceleration is what? 0, which means the net force is 0. So the forces cancel out. Excellent, excellent, excellent. Again, when you see constant speed, that means the exercise is being really, really easy on you. Constant speed, 0 acceleration, 0 net force. Give me a thumbs up if that makes sense. Because that's a huge deal. Cool, okay. What is the work done on the crate by the total force? 0. Why do you say 0? 0 times anything is 0. It could have gone an incredibly long distance, it doesn't matter. Okay, are we cool with 5-1? We got 7 minutes left. All right, 5-2. Okay, take a look at 5-2. Yeah, when in doubt, just choose 0. So when you're taking your AP Physics, AP Chemistry, and AP Calculus test, if you completely don't know, just go for 0. I'm absolutely serious. There's a lot of symmetry that makes things 0, so I'm absolutely serious. If you don't get hurt anymore by grading or by guessing, you used to, but you don't anymore. So if you don't get hurt by guessing, choose 0, because there's a good chance you'll be right. There's a lot of symmetries where things cancel out. Okay, here we go. Number 1. Oh, before we do number 1, in A, guys, in A, what kind of energy exists? Kinetic, and only kinetic. We only have 5 minutes left. We've got to move. In B, what kind of energies exist? Kinetic and spring potential. In C, only potential. How do you know this? Yeah, because velocity is 0. In D, what do you got? Only kinetic. Cool. Number 1. Examine the situation in part A of the diagram. What is the kinetic energy of the block? 1/2 mvi squared. Excellent. If you don't have a subscript, that's okay. 1/2 mv squared sounds good. What is the potential energy associated with the block's position? 0, exactly. There's no compression of the spring, no potential energy. So what is 0 plus 1/2 mv squared? 1/2 mv squared is the total energy, 1/2 mv squared. Number 2. This is a good one. Examine the situation in part B. What is the kinetic energy of the block? 1/2 mv squared. What is the potential energy of the block? 1/2 kx1 squared. Yeah, because kx1 and kx2 are different compressions. 1/2 kx1. And the total energy would be the sum of those, which is, 1/2 mv squared plus 1/2 kx1 squared. Okay, does that make sense? Cool. Number 3. Examine the situation shown in part C of the diagram. What is the kinetic energy of the block? 0. Why is it 0? Yes, exactly those things. It's fully compressing the spring, and V equals 0. It says V equals 0. The spring has been fully compressed, no velocity, no kinetic energy. What is the potential energy associated with the block? 1/2 kx2 squared. What is the mechanical energy of the system? 1/2 kx2 squared. Yay, we can add. Okay. Part D. Are we cool with part C? Okay. Part D. Examine the situation in part D of the diagram. What is the kinetic energy of the block? 1/2 mv squared. What is the potential energy in the block? 0. Why is it 0? Yeah, no compression. There's no compression in the spring. It's no longer touching the spring. No spring potential energy. And lastly, what is the mechanical energy of the system? 1/2 mv squared. Question. Next question. Okay. Sean asked a really good question that I want to address. So if we can just stop shuffling for just a second. I realize the bell's ringing in a couple minutes, and then I'm going to answer Jared's question. Okay, he asked, what if you put a negative in front? Is that wrong? And I will say, no, but the v squared is v squared. So since the v is negative v and you square it, that goes away. Okay? Realize energy is a scalar. So scalars don't really have positives and negatives. Their changes do. A change in energy can be positive or negative, but energy is just energy. Does that make sense? Okay, sure. Uh-huh.
On 5-4, it's asking like what's the velocity of the numbers. You want to use these numbers?
Yes, I do. Any other questions? Okay, cool. 5-3, 5-4, due next time. First thing. We'll go over that and we'll take our quiz.